Our next shortcut derivative rule is beautiful. It's the sum and difference rule, which means, well, if you're adding up a bunch of things, and you're like, well, I know what the derivative of 2x is. I know what the derivative of 3x is. And I know what the derivative of minus 7 is. The derivative of x squared is 2x. The derivative of plus 3x would be plus 3. And the derivative of a constant is 0. Wouldn't it be nice if this is what the answer was for the derivative? And for once in mathematics, when there's a simple way of doing something that you say, wouldn't that be nice if it worked? It does work. Okay? We're so many times in math, oh, wouldn't this be nice if this worked? Well, it doesn't. You have to do this long method instead. But in this case, it does. And that is our sum and difference rule. If you are adding or subtracting different things, and you can take the derivative of each of them separately, you can do that. So the way that it's written in the rule, it says, if you have y equals one function plus or minus another function, then the derivative will just be the derivative of the first one plus or minus the derivative of the second one. And this works even if you have 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. As many as you'd like added or subtracted together, we can just find the derivative that way. And again, okay, this would be 16x. This would be plus 3. Minus 4 would be plus 0. You don't have to write plus 0. You can just write it like this. But again, I want you to think about your definition of your derivative. Don't forget that. You still need to know how to do that. It will still be on your final exam. So you have to do at least one with your definition of your derivative. But if you had to plug in the x plus h, you'd have to plug it in for this x and for this x. Expand it all out. Simplify it. This is so much quicker. Imagine this one with the 1/5 with your definition of the derivative. You would have to probably figure out how to do a sum of fifths. I don't know what that is actually. It wouldn't be nice to work with. But now, we can just go another notation, okay? I'll just change it to this regular notation. The 2/3 would come out in front. That would give you 18/3. Subtract 1 from the exponent. The 1/5 would come out in front. That'll give me 2. Subtract 1 from the exponent. I could simplify this to 6 if I'd like. And so the first thing that we're learning is that we have certain derivative rules. We're going to add to these derivative rules as we go. But right now, we have the power rule, which is included in that, the constant rule and the power rule with the constant. Those can all go together. And now, if we're adding and subtracting, we can do the power rule for all of those ones, adding and subtracting. Okay? Sometimes we're going to get things where they don't match up with what we know so far. So this is squaring. We don't have a rule for squaring unless it was just x squared, but it's more than one thing squared. So sometimes we have to take some of our previous algebra rules and say, Well, what does it mean to square something? Squaring something means multiply by itself. And could I distribute this? Yes, I would get x to the 4 minus 8x squared plus 16. So I rearrange things to make it look like what I have rules for. And now, I have rules for adding and subtracting, and each one of those things individually follows the power rule. So now I can find my derivative. dy dx. 4 would come out in front. The 2 would come out in front. 16 would be 0. And this would be our final answer. So we had to take a little bit of time to rearrange things in order to put it into a form that we could do. And this is where some of your algebra skills from the past are going to come in and help you. Same thing here. Okay? I'm going to have to rewrite this in a form that I can do. Also, I could distribute this. So now I'm going to just take first the time to change this to 1/3. And now I'm going to imagine distributing this, and I have to remember my exponent rules. How do I multiply x to the 1/3 by 6x squared? Well, your exponent rule says if you multiply with the same base, you have to add the exponent. So right now, I'm just going to show it like this. That's what I would have to do. When I distribute that, I would add the exponent. Same thing here. I have x to the 1, and now I have to add the 1/3 to it. How do we add fractions? We need a common denominator. So it actually takes us longer to set things up than to actually do the derivative. So now that I have it set up, I can bring the 7/3 out in front. 6 divided by 3 is 2. 2 times 7, 14. Subtract 1 from the exponent, 4/3. 4/3 comes out in front. The 3 divided by 3 will cancel out. I'll just have 4. Subtract 1 from the exponent. So it takes us sometimes more time just to do the setup. Once things are set up, the derivative is a single step. No, not important. Not important. Whenever you're ready. This is like my phone just gave you. You can't just bring a note and say it's not important. Put it on a desk.
It's just to make you smile. Have a good day.
Right. Oh, I like it. It's a math joke. Share it with you, Pat. Same thing. We have to do a little bit of setup first. One favorite skill of mine, like fractions are hard, and you have to like add, subtract, multiply, divide fractions. But sometimes rules that students forget are unadding fractions, unsubtracting fractions, unmultiplying fractions, undividing. Like, how do you unadd fractions? Well, unadding fractions in this case would be like, oh, right before this, you had this. Right before you added the fractions together, this is what it would look like. You had the common denominator of 3x, and it would be one fraction plus the other fraction. And right before this question probably looked like this. Oh, I had 2/3 x to the 6th plus 3 over x. And in order to add those fractions, you would need to get a common denominator. But what we're doing is we're unadding the fractions so we can get it into a form that we can do the derivative of. This is now 1 power plus, oh, almost in the form. I have to do one more step. You see that I'd have to write this x as a minus 1. So we took something that in grade 9 your math teacher would have been happy, and we undid all the work to get it back to like, what were you thinking, the teacher would say. Why didn't you just keep it simplified? Well, it doesn't help us in this case. I have to unsimplify, unadd my fractions, and now that I'm in this form, I can do the derivative. 6 could come out in front. That would divide by this 3 and give me 2. 2 times 2 would be 4. Subtract 1 from the exponent. The negative 1 would come out in front. Subtract 1 from the exponent. So we had, again, some preliminary work to do to get this into a form that we could simplify. Work backwards. Okay? There's 2 work backwards. There's just the 1 work backwards. Try it first on your own. Put up the answer in a second. If I started with this unit showing you the shortcuts, do you know what kind of resistance you would have in the limits unit? You're like, no way I'm doing it the long way. No way. All right, add 1 to the exponent, 35x. How did you do? Good. And working backwards, did anybody add anything else? Like you could have +1 there, or +7. Or if you feel like there is a number that has been underrepresented in math questions for a very long time, they don't use 23. You could add 23 if you wanted, right? Because what's the derivative of 23? It'd be 0, right? You could make this really miserable and add a number with 785 digits. It would still be right. Be like, can I have extra time on this test, Mr. JR? I'm still working on this one. I haven't quite figured out what number I want to write down. But you don't need the 23, right? Sometimes we're going to find out later on that officially mathematicians like to go plus C. And they say C is any constant, any number you want. But unofficially, it just said find a function, so anything you wrote down would be right. You don't need that official plus C or anything else. You wouldn't have to write anything. 5x to the 4 plus 5x, which is what I'm guessing almost all of you wrote down, would be perfectly fine. All right, so this is where we're going to end for today.